Hi, I'm Coach Chuck from the National Free Flight Society Youth Development Program. I'm also the flight coach for the Albuquerque area homeschoolers, and I've been the ES at State for the last few years. I want to talk to you today about the 2023 flight events for Science Olympiad. These events are very similar for both the B and C class. We'll talk about the events and the rules, differences from the previous year, and differences between the B and C class. In this presentation, we'll go over the event description and the rules. We'll look at some of the sources where you can get materials, kits, and help. We'll look at some basic building techniques and some basic flying techniques that'll help you be successful. The event is a pre-build event, which means you build an aircraft at home and bring it to the event, and it's a powered indoor aircraft flown for duration. So it's the time in the air that matters. The aircraft can be made with any materials except for boron fibers. And one of the interesting things this year is the airplane must be presented in a box with the outer dimensions of the box specified. So the ES will measure your box, not your airplane. The score for the event consists of the best time out of 2 flights of duration. Kits, as I mentioned, are permitted, but they must be student built. It's an interesting aspect of this. I ES the nationals last year, and one of my questions was always who built the plane, just to break the ice. And I actually had one team kind of smile and say coach did, and it was an immediate disqualification, unfortunately. So the plane must be student built. The event is not a design event like some of the other pre-build events, but it's a flight optimization event. So building of the plane, designing of the plane is not the real key, although there are some variables you can work with. The real development in this event is the flying. So data collection and recording during your flying sessions is extremely important. It's critical to your success. You do need to build light to try and reach the minimum weight of 8 grams. You want to be right at that minimum if at all possible. And 8 grams is not that hard to reach if you're careful. You want to build accurately. A twisted, crooked plane just won't fly well. Most of the planes that I've seen with less experienced schools are actually built quite well, and they just need to be trimmed more properly. So we'll talk about that a little later. It takes lots of flying, lots of data to be successful in this event. So plan appropriately, get some gym time in your gym or a church gym or a warehouse or something. The event parameters. The plane can be kits, they can be from plans, they can be a self-design, they can be coach's design. Any source of a kit or a plan is acceptable. However, the kit cannot have anything that's pre-glued or pre-covered. The exception there, as we found in the FAQs in previous year, is if the plane has, say, a full molded styrofoam wing and it has a colored skin on it, that's not considered pre-covered. When they talk about pre-covered, they're talking about an open frame structure on the wing with the thin plastic covering. The plastic covering cannot be pre-installed on any surface. This year, the interesting aspect is the plane must fit in the specified box, and the box is a different size for B and C. It has to fit in the box in flight-ready configuration, and nothing can bend getting it in and out of the box. So the box is used essentially as a measurement device, but the box must be delivered to the table with the plane in it. So the intent here by National is that it is also a transportation aspect of this event. If you design the plane right to the limits of the box, you're going to possibly damage the plane in the box. but on the other hand, you'll have a more competitive airplane. I would not recommend transporting the plane in the box, but just bring it to the table. Put it in the box when you get into the gym and bring it in the table. Have a bigger box to store it in while you transport. Don't push the dimensions, especially on the box. Let's say you build it out of cardboard or foam board or something. We've seen where the edges of the box will warp outward, and that will get you tiered. So leave a little bit of room, make sure your box is straight, bend it as necessary to keep it within the limits. The propeller can be built or purchased. There's a 10% bonus for a black marker between two ribs or on one tip plate. Plane has to be labeled for identification. And up to 2 planes or 2 aircraft can be in boxes presented for inspection. Has to be separate boxes. It's a 2-student team for the flight event. More students can participate in the build if necessary, but two students compete. Of course, a non-compliant plane or box this time will be tiered. Additional parameters of interest: the propeller diameter is not specified, it's not limited, but it has to be installed on the plane in a flight-ready configuration and fit in the box. If the propeller is a flaring propeller and has a lot of area in front of the spar, it can't be compressed by the box. So look at that when you're installing the plane in the box. The plane has to weigh a minimum of 8 grams without rubber, and the rubber is 2 grams maximum, so you end up with an approximate 10-gram flying weight. This is a fairly heavy airplane. The rubber at 2 grams includes any O-rings. It can be masked before or after lubing. We highly recommend you lube the rubber with a silicon-based lubricant, not WD-40. You can get shock oil for RC cars. You can get leather preservative for your parents' car. Something like that will be fine as a lube. You can check up to 6 rubber motors, or if you have 2 propellers on the plane, 6 sets of motors. The total rubber mass on the plane cannot exceed 2 grams. So if you have a 2 propeller plane, you would have 2 1-gram motors. But it's each set of motors must stay together. You can't mix and match after signing in with your motors. Oh, one other area this year, in addition to the aircraft fitting in a box, which gives you a lot of flexibility, the aircraft shape is not specified. So the plane configuration can include any wing configuration. While most planes will be a monoplane, you can consider options such as a tandem. That's where the stabilizer is the same as the wing. That might be hard to trim on this year's platform. A biplane gives you a lot more wing area within the volume of the box, or even a triplane could fit in this year's boxes. One of my warnings on a biplane or a triplane would be it severely complicates the number of adjustments you need to make, the number of variables that you have on the plane. For a regional and state, it's probably a waste of time to be pursuing a biplane or a triplane. But there is some gain to be had by going to a configuration like that. But until you can get a monoplane, a basic kit flying over 2 minutes, there's no sense in pursuing something advanced like that. This year's rules actually allow for a helicopter or a glider, as long as it fits in the box and fits the weight minimums and the maximum mass of rubber. However, an 8-gram helicopter is not an ideal flying machine. You're going to do much better with a basic airplane. The glider, by rule, would have to have the rubber go with the glider, not stay on the launcher. That's a little backwards, and an 8-gram glider is not going to glide very long. Again, I think while there is flexibility in the platform here, your best approach is a kit or your own design that is a basic monoplane, conventional layout airplane. but the rules do allow for a lot of flexibility as long as it fits in the box in its flying configuration. Which dimension fit what part of the box is important. The box has 3 different dimensions. I would put the longest dimension being the motor stick length, because these planes are short coupled this year, meaning the stab is too close to the wing, and that makes it hard to trim. The longer you get that motor stick, the easier it's going to be to trim the airplane. So you want the motor stick going the length of the box. But the wing doesn't necessarily have to fit in the width of the box. You'll see the Freedom Flight models, you tilt the wing diagonally in the box, and that gives you considerably more wing area. It's worth doing. The format of the wing is wide open. You can have simple dihedral, tip plates like a lot of the kits have, or a polydihedral. You can even make an elliptical wing if you're so inclined, but that's a lot of work. So basically, this year's platform gives a tremendous amount of flexibility in the design of the plane. But for basic flying at the regional and state level, a simple monoplane conventional configuration is an excellent place to start. The flight log is critical. Now, there's minimum requirements for the flight log. If it's missing, it's a 20% penalty on your score. It's a little different than previous years. It used to be a 30% penalty. Incomplete, it's still a 10% penalty. The reason it's 20% now is they've separated it out, the design log, as a separate item. 10 flights minimum must be recorded. Numeric values must be in proper units. Make sure you put units on it, but this year they're allowing both metric and English. They just must be correct units for what you're measuring. Now, if your torque meter is one of the low-cost torque meters from some of the suppliers that just has numbers without units, just put in parentheses arbitrary units, because it doesn't have a real calibration. The required entries on the flight log are the motor size before flight, and that could be the length, that could be the width, that could be the mass. It's not clearly identified what motor size is, because that's kind of an open parameter. It's an important parameter, but different teams will measure in different ways and interpret that data. We include the motor mass, the motor loop length before we stretched it out, and the width, or the grams per inch, what I call the linear density of the motor. The number of turns or the torque at launch, not fully wound, but if you're unwinding, you have to report either the number of turns or the torque that you had at the time of launch, and then the flight time of the flight. Then you have 3 additional columns at a minimum that you get to choose what you put on there. Might be the altitude the plane reached. I'd suggest that one. It's important. The maximum torque reached. The remaining turns or remaining torque at the end of the flight. That's important. The number of unwinds. If you wind it up to near braking and then unwind it to a launch torque, that's a good number. Details of the propeller. If you have a number of propellers, some identifying number or dimensions of the propeller, say the pitch, the diameter, or just an identifying number. Anything else you can think of that affects the flight time would be important to log. More log entries is better than fewer. It's critical that you log things in order to improve your flying skills. The next log is your build or design log. This is now separate from the flight log. It's judged separately, and it's worth a 10% penalty if it's not included, and a 5% penalty if it's incomplete. It must include the materials used in the construction of the plane. That a list would be fine. A labeled diagram identifying the parts of the plane. It no longer says the parts and the function, but just identifying the parts. This could be the drawing sent with a kit, or we simply photographed our plane and then electronically added labels to each of the parts, and that was acceptable. And the design log also needs to include a cover page with the team name and the team number. This will change for your different competitions, state, regional, whatever. This is an area that was left off by a lot of people last year, and it cost them an incomplete on the log. If you have computer numerically controlled machines making any of your parts, this would be 3D printer, CNC router, laser cutter, any of that sort, and you've used parts made in those ways, you have additional requirements in a log. Now, if these parts come in a kit, like laser cut ribs in a kit, or a 3D printed prop hanger in a kit, you don't have to include this part of the log, according to FAQs last year. If you do print your own, cut your own, route your own with your own tools, you need to provide information about the tool and the software and the materials used. You have to detail where you've got the software, the digital files that you used, especially if they were downloaded, and a description of how the final device was constructed from the tool created components. Again, you do not need to include that if the kit included manufactured parts using those methods. Finally, the students must be able to answer questions regarding the design, construction, and operation of the plane. This is in there intended so that the ES can determine that the students actually built the plane. The flying process, when you go to the event, it must be indoors, and by rule, the room dimensions should be published in advance. If you don't see the room dimensions a week before the event, start bugging the event director and get those room dimensions. What's particularly important is the ceiling height. They should have the air conditioner turned off or the heating unit turned off so that the air is not moving rapidly. That doesn't always happen, but it's something you should ask about if it's not off. Once the student enters the competition area, they cannot receive coaching or communication. This is grounds for tiering. So coaches, keep your hands down, keep your eyes on the plane and not on the students, and don't try to wave them to do something different. It's a good way to get tiered. Only the participants may touch the plane. This is to keep the plane from getting broken. Even the ES is not supposed to touch the plane. Don't let the officials attempt to measure or weigh your plane. Have them show you the scale and the measurement equipment, and you present the plane, or this year, the box, to that measurement equipment. Now, in the rules, it says nobody else can touch the aircraft. So presumably the ES can touch the box this year, but I would highly recommend you go by the spirit of the rule and nobody touches your stuff and you measure it to the CD's or the ES's satisfaction. Trim flights are allowed, but once you're checked in, as soon as you get your rubber motor back from the ES, you're on a 10-minute clock. You're permitted to have trim flights during this time period, but you must announce them as trim. If you fail to announce it as trim, it's assumed to be an official flight. It's the ES's discretion whether test flights are allowed prior to check-in. It depends how busy the gym is and how much space there is. They do not have to allow that, but if they do allow it, they should allow it for everybody. Generally, I believe the rules do not allow trim flighting outside of your 10-minute clock in the last hour of competition during the day because things get hectic. When the student receives their rubber motor back from the judges, a 10-minute flight clock starts. There's no longer a pre-flight period. There's no timeout for retrieval of the plane or repairs. Any flight starting in the 10-minute window may go to completion outside that window. but no additional flights can start outside the 10-minute window. So instead of an 8-minute flight window, we have a 10-minute flight window, but it includes all your flight prep and initial winding as well. It simplifies it quite a bit from what we had the last few years. Your score is the best duration of the 2 official flights plus bonuses. So if you only get 1 official flight, there is not a big penalty. You just don't get the opportunity to improve your flight. And any construction violations, either on the box or on the plane, are grounds for getting tiered. Some of my observations as a ES, issues that I see, and observations. The biggest one being insufficient logs. The log is up to a 30% total penalty if you don't have either log, and it's a simple way to keep your points. You only need 10 entries, but we see a number of people come in with fewer than 10 entries. We see a number of logs come in without the minimum of 6 columns. And they should be numerical items in each column. Of course, I identified prop selection as one of the possibilities. We just label our props A, B, C, and so forth. That's one of our columns, but we have way more than 6 columns in our log. These logs, while they're a requirement for your full score, they're also a critical element of improvement. So log every flight and you'll have no problem meeting this requirement. In other years, we saw either a lack of units or wrong units. We required metric in the past. This year, metric or English will be fine. So feet for altitude will be just fine. But make sure you have units on every numerical value. Really simple one. A number of teams last year lacked the required cover sheet, and that's an automatic incomplete on the design log and a 5% penalty. That's something you can scratch out by hand right before the event. Crooked construction. This is something we saw a lot of, and accurate construction is critical. Build on a flat surface. You can use a ceiling tile or some foam board from Hobby Lobby to build on and get your plane straight. Untrimmed models is a big area. A lot of people that appeared they had very few, if any, flights on their model, and it showed in their flying. They were well-built models and just didn't fly well because they had never flown them. It takes time in the gym. The build is a minor part of this event. Too much glue is a big issue. Very heavy models, and most of the weight comes from excess glue. Any of these kits should build around 5 to 6 grams if you're careful with the glue. Most of the planes we see are reasonably built, but they're not reasonably trimmed. I mentioned this earlier. You need to set up the plane to do a circle in about 60% of the size of the gym for any reasonable duration. If the plane goes straight, you're limited by the gym size to what duration you're going to get. You trim the plane for perfect flight at low power and then work on minor adjustments for high power so it properly climbs out. But if it's not trimmed for low power, messing with it at high power is just chasing in circles. It's not going to solve the problem. We'll talk a little more about trim later in the presentation. Another big area is not flying the same in practice and competition. I've seen teams practice the morning of the event in the gym of the event and get some very good flights. And then they watch somebody else fly and they change their approach, launch with more torque, wind it harder, whatever, and they crash and burn. You have to fly the way you practice. Don't be intimidated by what the other teams are doing. Better to take a second place than to crash and burn and get a last place. Some other thoughts on this event. The box dimensions we have this year, it's basically a letter size box, file box for C and a legal size for B. These dimensions make for a very short tail moment, meaning the distance from the wing to the stabilizer is rather short, and that makes it challenging to trim. You're going to want, once you get the plane starting to fly, you're going to want to make very small adjustments to either the wing incidence or the center of gravity moving the clay on the plane. Very small adjustments will make a big change because this is a challenging plane to trim. They will fly well once you get them trimmed. So therefore, if you want to improve, you got to spend more time in the gym than you did on the build. Keep your detailed logs. Read and follow the rules carefully. A lot of people come into the event and don't know the rules. Don't expect the CD or the ES to know the rules. I make sure I know the rules when I'm an ES, but it doesn't always happen. You need to know the rules better than the ES does. Use resources, especially the online forum at Scioli. The online forum is great because it archives people's questions, and expert coaches like myself, Coach Brian, Coach Jeff, will respond in detail and help you out. It's better than, say, Discord, where the responses get lost in the noise. So I strongly recommend using the online forum at Scioli. Okay, let's talk about sources of your materials, kits, supplies, and sources of help. The first kit is the Ward Science. This is the official Science Olympiad supplier. Their kit basically includes a bunch of sticks, tools, and glue. It's more of an open-ended kit. Their design isn't even always updated. It might be last year's design. They expect you to put the work in to make the design and make everything work together. Officially, we're supposed to support the Ward Science. Unfortunately, especially at this year's price, I can't recommend it. Freedom Flight Models makes a very competitive kit. It tends to be more complex than some of the other kits, but it's consistently in the top 10 at nationals. It's consistent quality, very extensive instructions. Freedom Flight Models, Dave also has a full stock of accessories, a torque meter, winder, counter for the winder. He'll cut you rubber at any width you want. He's got a selection of propellers. Very well thought out kits, very successful designs. Highly recommended. Second source of kits is J&H Aerospace. Josh and Hope Finn. It's a very competitive indoor design, and Josh's planes are rapidly becoming a high-level competitor to the Freedom Flight models. Generally, and this year is no exception, Josh kits two planes. One's an entry level. This year it's called the Senior Flyer. It's simpler, it's all balsa, and it may be easier to trim. You can see it in the top picture here. It's got a smaller stabilizer, a slightly smaller cord on the wing, and ends up being easier to trim. It's not going to be the winner at the Nationals, but it can do very well at regional and state. His second offering is the Stinger. It has carbon for the leading and trailing edges. It's a little more expensive. It's got a wider cord on both the stab and the wing, and that makes it a little more difficult to trim. But once you get it trimmed, it will have better times on the flights. Again, for regional and state, you can probably do as well with either of these kits, and the Senior Flyer may be a little easier to get flying successfully. Laser Cut Planes is out of Colorado. John, the gentleman that owns the company, is an educator and aims all of his offerings at students. His kits feature very simple building with interlocking designs. It almost falls together out of the box. It's an operable design, meaning it will fly, and it will fly successfully. It will fly well. It should do well at regional and state. It's low cost compared to the others. It's all balsa. He's got photo instructions, but because of the self-jigging nature of it, he doesn't have plans with the plane. Just a very detailed instruction manual. He does aim the manual at students, and it's known for simple assembly. I highly recommend John's kits. He has two kits this year, the Box Elder for C and the Box Concerto for B. They should prove to be both very good flying planes, and he has improved his offering on the propeller on both of these. We'll find that the propeller is key to success once you have a decent flying airplane. Guru Engineering is a fairly recent addition out of West Virginia. He has a nonprofit organization trying to give a low-cost option for Science Olympiad planes. However, this year, some of the reports I've seen indicate that for whatever reason, even though it looks similar to other planes, this plane may be very difficult to trim. So buyer beware. That I have not built one or tried to fly it, but the reports back that I'm seeing is that for whatever reason, it might be the very small vertical fin on the tail. It's a very difficult plane to trim. You'll need some accessories. The biggest one being a winder. I highly recommend a winder with a counter, a torque meter, highly recommended, and a pitch gauge for your propeller. Indoor free flight supply supplies things for more advanced airplanes, but he will also cut rubber to whatever width you're interested in. He has a lot of basic tools as well as advanced tools. And as you progress in indoor flying, you'll be friends with Indoor Free Flight Supply. Freedom Flight Models, one of the kit makers, has a full line, including a winder with a counter. He's got a good torque meter and a bench to, or a winding jig to mount the winder onto after you wind, so you can transfer the rubber to the plane. Very good supplier, has everything you need for Science Olympiad. FAI Model Supply has rubber. They have some Icaro props. I'm not sure what's in stock this year. A lot of people have gone to the Indoor Free Flight Supply props, which are a newer version of what Icaro was selling. J&H Aerospace is also a complete indoor free flight supply company, indoor and outdoor, has an extensive line of planes and equipment. And Josh is very supportive of the Science Olympiad community and has geared a lot of offerings, including torque meters and prop pitch gauges and so forth for the Science Olympiad community. Some of your more advanced supplies, such as lightweight covering and a rubber stripper to strip your own rubber down to whatever width you want, is available from Indoor Model Specialties. Now, Ray at Indoor Model Specialties has been shut down for COVID. He's an older gentleman, and I don't believe he's opened his doors yet, but you can try to contact him, see if he'll sell you something, even though he's not officially open. The main thing we used to get from Ray for Science Olympiad is the lightweight covering, but it's really not needed. You can use veggie bags from your local grocery store, and that's plenty light enough for an 8-gram plane. Okay, Hip Pocket Aeronautics is a source of plans and additional help. There's a forum there with a Science Olympiad thread, and it's very helpful. And in the plans section, plans library, look for a plan by Bill Gowan. He makes a plan every year for Science Olympiad. Look for assistance from Bill, from Brian Turnbull, from myself, Chuck Andraka, and Jeff Anderson sometimes on there, as is Josh Finn. I think Josh goes by the user handle of MaxOut. So that's a good resource. The National Free Flight Society at freeflight.org has a Join, Learn, Fly Science Olympiad section, and we try to keep that up to date with videos, plans, how-to guides, etc., links to a lot of these other resources. So we want that to be your home base for where to get information. The Scioli online forums are excellent because they archive your questions, and you can find if other people have asked questions. You can find forums from prior years and see how we've answered questions in the past. minimizing weight gain, there's a link here for a good document on how to minimize your weight gain while you're gluing things. And there's another link for just some basic building hints, how to keep your plane light while building it strong enough. So there's links on that page. You're welcome to go check them out. But keep in mind that the freeflight.org site, we will try to keep up to date with the latest offerings of help for you. Let's look at some of the building techniques so you can have a successful build and move on to the most important part, flying the plane. First thing is weight is everything. If you pour your glue directly from the bottle, your plane will be heavy. CA, or cyanoacrylate super glue, is very heavy. I use thin cyanoacrylate, and I use a capillary applicator. You can see the picture here. It consists of 2 pins in a scrap of balsa, and you pick up a little drop of glue. You can squirt your glue into, say, a margarine lid or something like that, some plastic leftover lid, and just dip that tip into it, and that's plenty of glue for a joint on these planes. If you use medium CA, you can use the tip of a toothpick to pick up a fairly small drop. The balsa density is important. Most of these kit suppliers will give you decent grade balsa. You want something in the 5 to 8 pound per cubic foot. You can calculate what that would weigh in grams and take your scale to the store with you and weigh different pieces of wood. If you're getting your wood from Hobby Lobby, a lot of that wood might be up in the range of 12 to 20 pounds per cubic foot. Way too heavy for a plane that's got to weigh 8 grams. 5 pounds is probably on the light end. 6 to 8 pounds per cubic foot is an ideal weight for the wood for these planes. So generally speaking, if you get the lightest wood they have in the local hobby shop or Hobby Lobby, you'll probably be okay. But you're going to see a huge difference in mass between the lightest and heaviest sheet at the store. You need to build straight. You're going to need to build with fixtures. If you use a foam board, use a 1/2 inch thick foam board from Hobby Lobby. That allows you to stick pins into it. You can put your plan onto that foam board and then cover it with wax paper and tape your wax paper down with some Scotch tape. Then pin through it and you'll be fine. That'll get things straight. Strength is important. Sometimes some of the key joints, if you're having trouble, especially where the leading edge of the wing meets the tip rib, will come in and wrap with 1 or 2 wraps of thread and then a dot of thin CA, and that makes it extremely strong. I like carbon for the wing leading edge and trailing edge. We kind of pioneered that. Most of the high-end kit makers are now offering carbon. It's lightweight, it's stiff, it is heavier than balsa, but it won't change with moisture in the air. The covering, most kits include ultrafilm. This is a lightweight film. It's overkill for an 8-gram plane. You can use grocery veggie bags, not the bags you get at the checkout counter, but the ones that are on a roll in the vegetable section. Just grab a few of those. Those make great covering for this class of airplanes. To prepare for covering, completely build your structure. It should be flat at this point, and then build a frame out of scrap balsa. You can see this in the lower picture here, just standing the balsa wood on edge. And then we put a little bit of Vaseline around on that structure. You could, not on the airplane, on the scrap structure, you could also use chapstick. Then we take the covering and we ball it up as tight as you can possibly do. The covering for this whole plane will probably end up between the size of a pea and the size of a marble when you squeeze it all up. Carefully unfurl it with a stretching motion. Don't pull it. Comb it with your fingers. Then ball it up again, unfurl it again. Now attach it to your frame and carefully stretch it out. You don't want it tight as a drum. You just want to get the big wrinkles gone. So by balling it up, you get thousands of micro wrinkles, and that gives it some flexibility so it's not going to warp your frame. So don't want to get it too tight, but you want to get the big wrinkles out. Now, we like to use 3M77. It's available at Walmart and some of your other stores. I believe Amazon carries it too. It's a spray adhesive, a very light coat. Just spray it from 12 inches away and go, psh, and that's it. That's plenty of glue on the frame. You spray it on the top of the frame. You might take a second spray from the other direction if you're using the carbon for the leading and trailing edge, and then turn your frame over and drop it onto your covering on this frame. Make sure it sticks down all the way. Run your finger around it to stick it down. Allow it to cure for an hour or so, and then cut it out. I wouldn't recommend cutting it with a blade. I'd highly recommend a soldering iron. Just a cheap one from Harbor Freight would do for probably $5 or $10. Or you can use a cartery available from Indoor Free Flight Supply if you want to spend about $15 to $20 and have more control without a cord running to an outlet because it's battery powered. Okay, now that you've built, we get to flying. Let's talk about some of the techniques for flying. Okay, trimming is an area where I see a lot of development needed with newer students. This is what makes and breaks a successful airplane, and just a little bit of trimming can go from a frustrating, not flying airplane to a very decent flight over a minute. First thing you want to do is verify the mass of the airplane. Check it often, and as you've added glue to repair things, take off some of your clay ballast if you had some to keep yourself right at the 8-gram minimum. We use modeling clay available from Hobby Lobby. You can also use the blue tacky putty that's used for mounting posters on the wall and that kind of thing. But in addition to the mass, the center of gravity is very important. It's a critical trim location, and this ought to be in your log, a position of the center of gravity relative to the front or rear wing post. You want to verify that often, especially if you've added glue out at the tail of the plane. Make sure you haven't moved your CG back. This year's plane with the short tail moment is very sensitive to the center of gravity, so check it often. Your decollage should be set to about 3 to 8 millimeters. Decollage is the difference in angle, see the lower picture here, between the front wing and the rear stabilizer. Decollage is what gives the plane lift as it moves forward through the air. The difference in angle between the front and back is what's important. And typically on planes of this class, we'll set it to about 5 or 6 millimeters of decollage. We'll have the stabilizer glued flat to the motor sticker tail boom, and then have a difference between the front wing posts and back wing posts of about 5 or 6 millimeters. That's a good starting point. Your CG should be set per the plan. If the plan doesn't have the CG or you're making your own plane, start at maybe 1 inch to 1.5 inches ahead of the rear wing post, depending on the chord of your wing. Wind lightly. You don't start off with a full wind, but maybe 500, 600 turns on the rubber. 60 turns on a 10-to-1 winder would be plenty. Launch the plane straight ahead with a light toss and watch how the plane behaves. You want to get a little bit of stall. So probably when you first fly the plane, it's going to dive a little or go straight ahead. Increase the wing incidence. So tilt your front of your wing up a little bit at a time until you just start to get a stall. And then decrease it until the stall just goes away. At low power, this gets you very close to a well-trimmed plane. Now, if you have to change your incidence a lot from that 5 or 6 millimeters on your wing, think about moving your CG back until you see a stall and then move it forward just a little bit. Either one will get you there. Generally, if the CG is where the plan says it should be, then you want to adjust with wing incidence. Once you have the plane flying good, the other thing you want to watch for is if you touch the ceiling or the girders, or if it gets knocked by the air conditioning. If it dives all the way to the floor, it's not a stable airplane. And what you want to do is move the center of gravity forward toward the propeller and retrim the incidence of the wing, again, to get you right on the verge of a stall. If it hits the ceiling and just drops a few inches and quickly recovers, you can try moving the center of gravity back, make the plane less stable. It will be more efficient the less stable it is. There's going to be a fine line. You can have a very unstable plane, and if you're flying in stable air and can keep from touching the ceiling, that's going to give you your best times. But you risk, when you only have 2 official flights, you risk a disturbance in the air killing your flight. So you want some stability. Trimming may take 1 or more flying sessions where you never even get any full wind launches. You're just working on trimming. So be patient on the trimming. As we continue our trimming, once you have the plane flying well at low power, simulating your cruise and letdown, now you want to progress to higher power launches. You don't want to go to full torque at once. Just add a little more torque each flight and adjust the launch torque to the room height. You should find the plane climbing a little more as you increase torque until you can get to the ceiling. At very high torque, some planes may tend to roll into the circle. Then the plane will dive in that roll, a spiral dive, and go down to the floor instead of climbing. If this occurs, you may want to increase your inboard wing or left wing wash in. Wash in is a twist of the wing so that the left wingtip has more incidence than the right wingtip. You want to adjust the circle of the flight path to fit in 50 to 60% of your gym size. So if it's a 50-foot wide gym, you want to fit in about a 30-foot diameter circle. The rudder offset, or the steering, if you will, the yaw control at the back of the plane, will have a greater effect at your high torque or high speed flight. So your first a quarter or so of the flight. Tail tilt has greater effect on the lower speed. So that's your relative position looking from the rear of the plane of the stabilizer and the wing. So if the stabilizer is tilted toward the outside of the circle, its lift pulls the tail toward the outside of the circle and pulls the wing around in a circle. And this tends to have a greater effect on the low speed phase of your flight. As you fly, you want to record all of your parameters for every flight in the log. If you don't record it, you can't remember what worked and what made it worse. Change one thing at a time and try another flight. Change one thing, try a flight. That way you can separate the variables. Once you have the plane flying well, in order to get a longer flight, you want to optimize the combination of the rubber and the propeller. You can change the propeller. You can adjust the propeller, adjusting the pitch of the propeller and adjusting the flex on a flaring propeller, adjusting the diameter of the propeller, perhaps trimming a little off the diameter if you need a smaller propeller. You can adjust the rubber width and the rubber length of the loop at 2 grams. You want to be right at 2 grams. But the different combinations, as you try things, the stopwatch is going to tell the story. If the plane won't climb at your highest torques, try thicker rubber, try less pitch on the propeller to get more power to get it spinning faster, or less diameter on the propeller. I have a little section here on half rubber flights. It's not critical, but a half rubber flight is convenient if you're practicing in a gym that is smaller than your competition gym. Half rubber means you're going with a 1 gram piece of rubber of the same width that you intend to use at 2 grams, so it's half the size loop. You replace the back half of the rubber with a stick that weighs that weighs 1 gram. So now your total rubber weight with the stick is still 2 grams, and the length is the same as hook to hook length is the same. So your stick should be half of your hook to hook length on your airplane. Your rubber may be longer than that. A half piece of rubber with the full mass, so another gram on the stick behind the rubber, will give you half the altitude and half the time as the full piece of rubber. So if you're shooting for a 30-foot gym, and your gym's only 20 feet tall, you use half rubber and you'll see a 15-foot rise, and that will get you very close to a 30-foot rise with a full piece of rubber. So it's a predictable way of practicing for a higher ceiling. It's a lower risk way of practicing, even if your ceiling is the same height as the competition ceiling. If you have girders that the plane can get stuck in, if you use a half piece of rubber, then you reduce your risk. You're not going to get the plane caught in the girders while you're trying to get the basic trim of the airplane. Most important thing is get in the gym. Winning requires a lot of flights. Successful flying requires a lot of attempts at flying. So on winding the rubber, we're putting turns into the rubber. We're storing energy in the rubber. As the rubber winds up, if you're just winding it like with your finger on the propeller, you're going to see the rubber knots up. Every time it knots up, you've got a little loop of rubber that is no longer getting twisted and is no longer participating in the storage of energy. It's locked in what it can store. So we stretch the rubber as far as we can, usually 6 to 8 times the original length, and start winding from there. We'll wind about half of our winds into the rubber at full stretch, and then start walking in. We want to wind, let's say we want a torque of 0.1 ounce inches at launch. If we wind up to 0.1, then when the rubber unwinds, it unwinds at a lower torque than it had winding for the same number of turns. So the torque drops down. If we instead wind to braking, let's say braking is at 1.2 ounce inches, and then we unwind to our launch torque, we can fit as much as twice the amount of energy into the rubber, twice the number of winds, as if we just wound up to the launch torque. This is called hysteresis. So you want to wind to maximum torque just before braking, and you will break a lot of rubber before you figure out where it breaks. A torque meter is critical during this, and wind counting is critical. We lubricate the rubber with a silicone oil or Armorol, which is a silicone-based preservative for leather in your car. We put a little of that in a Ziploc bag, drop the rubber in, rub it so it doesn't get all over your fingers, and then pull the rubber out and wind it. We like to wind off of the plane so that if the rubber breaks during winding, it doesn't destroy the airplane. Plus, when you're winding off the plane, you're winding on a torque meter, and you can monitor the torque as you wind. Again, we wind to somewhere near braking, maybe 90% of braking on the torque, and then back off from that to our launch torque. The launch torque will determine in some degree how high the plane goes upon launch. So start with a lower launch torque, unwinding more from your peak, but you're always winding up to peak and then backing off. To evaluate the rubber after your flight, if the flight went to your goal altitude, so if you're in your final gym, your flight gets very near the girders, or if you're doing half winds, it gets to your goal altitude, then when the plane lands, look at how many winds are left on the rubber. If it's a lot of turns remaining, you need thicker rubber or a smaller prop, a lower pitch or lower diameter prop. If you run out of rubber winds in the air, then your rubber's too strong and you want thinner rubber or a higher pitch on your prop to load up the rubber a little bit more. So the number of turns remaining is one of the key evaluations of the matching of the rubber to the propeller. Once you've done your low power flights, what you're looking for is very small changes and record any changes you make. You want the plane to fly very well at low power because most of the flight is spent at low power. The plane will climb, then the plane will cruise, which is staying at pretty much the same altitude, and then we have letdown. Most of the time is spent in cruise and letdown, not in the climb. So it's the low power flight that you want well trimmed. Now you go up to higher torque incrementally, not all at once. And if the plane tends to dive, well, if it tends to dive during low power, then you increase the decollage, raise the front of the wing or the back of the stabilizer, or you move the CG rearward. If it stalls at low power, then decrease the incidence of the wing, decrease the decollage, or move the CG toward the front of the plane. Now we go to high power. If it was flying well at low power, but it stalls at high power, you may need to add some down thrust. That's getting the propeller to point downward just a few degrees. You can do that by bending the prop holder or breaking it off and re-gluing it, depending on your type of prop shaft holder. You can also add incidence to both the wing and the stab. So your decollage doesn't change, but you're effectively adding down thrust by doing that. If the flight is okay, but the plane just won't climb, you may need to decrease your prop pitch, get a little more power in the first part of the flight. Or if the plane is tending to rapidly fly in a circle with the wing tilted inward toward the middle of the circle, add a little bit of wash in. That means raising the left wing tip leading edge a little bit, and that'll roll the plane a little more flat at high power. You don't need a lot of that, but some reports on this year's planes indicate you may need a centimeter or more of washing, and that's a lot compared to previous years. Again, after you've made those adjustments, work on your decollage, the angle difference between your wing and your stabilizer at low power until you just get a stall and then back off slightly. So you always go back to that low power trim flight when you make a change to the trim of the airplane. Get the low power flight correct before you go back to high power. So that should get you in the air and get you some ideas on how to improve your flight, how to get the plane basically trimmed, and you should easily, with any of these kits, get over a minute of flight. Once you get to that minute level, now you're doing fine tuning on the rubber width and or propeller, and you can start worrying about details of the design of the plane to maximize the area. Any of these kits should easily do a minute. And until you get a minute on the flight, you don't need to spend a lot of money on extra equipment or specialized airplanes or specialized designs. You just need to get the basic trim correct on the plane. You can follow up with me. I've left my information on this slide. You can text me or email me. You can also contact me on the Scioli forum. So I hope this is a help to you. I hope this helps get your team in the right direction for a rewarding and successful flight. Thank you for your attention.